Now we're going to combine the horizontal and vertical transformations of a graph. And so in this example, I have, again, the square root of x, and then I have a transformed version of the square root of x. Here I have a negative multiplied on the outside, a -2 on the inside, and a +3 on the outside. And so we have a combination of both horizontal and vertical transformations here. When I apply these transformations, I apply them inside out. And so the ones that are closest to the x, I would do first, and then kind of work my way out on these. So here the first thing I would do is I have the x -2. So that -2 in there, notice that the h value would actually be 2, and so that gives us a horizontal shift to the right of 2 units. Okay, and it'd be the opposite of the sign of what's inside. Now I'm going to plot these graphs in succession so that you can kind of see how the different transformations build. So this first one with the -2 I'm going to put in green, and let's see, so a -2 means a shift to the right 2, so each point shifts right 2 units. Let's see, so I have 2, 0. I'm going to have, instead of 1, 1, I'm going to have 3, 1, and instead of 4, 2, I'm going to have 6, 2, which would actually be kind of off the graph over here, but close. And there's the first transformation. That's our horizontal shift to the right. Then, from there, the next operation out would be the multiplication by a negative. And so that's on the outside, which would be a vertical reflection across the x-axis. So every point gets reflected down. So instead of +1, we'd have a point here at -1. Instead of +2, we'd have a point out here at -2. And the graph then goes down and to the right instead. Okay, and then finally, the actual graph of the function g takes that blue graph that I just drew and adds 3 to it, so shifts it vertically 3 units. And so the end point here goes from the x-axis up 3. Okay, and then I'll erase all of this. Okay, so there's my point. The next point is over here. Let's see. 3, -1 is going to increase 3 units, so that would be 3, 2. If I were to add 3 to that, let's see, that would be right about there. And then the final point, instead of being at 6, -2, it would be at 6, 1. Right, so 6 is kind of off my graph, but it's out there somewhere. And so my graph is going to start up here on the left, go down to the right, something like that. So that red graph is the actual graph of negative square root of x -2 all plus 3. Okay, and so this graph gives you 3 different transformations, and what I've done is plotted them in succession until I get to the last one, the red graph, which is the final version of the function I have drawn up here. Okay. Now we can do this for any function. I'm picking on the square root of x because, like I said before, it's not symmetric, and so you don't get any weird situations like, I'll show you one here. If I were to use the function 1 over x, our reciprocal function, for instance. That function, its graph, is in the first and third quadrants. Now, if I were to do a vertical reflection of that graph, right, a vertical reflection, if I were to plot that, let's plot that in red. let's do that as g of x. A vertical reflection would be multiplying the entire function by a negative, okay? And so what you would get is this top portion reflects down. Oops, not drawn very well. Should be a pretty good mirror image here. Okay, that's better. And then this bottom portion would reflect up. Okay, and you get this graph. Okay, that's a vertical reflection. The red one is. Now if I were to do the same sort of thing but with a horizontal reflection, then horizontal reflection, I'll call it h. That would be 1 over negative x. Notice I put the negative in with the x because that's the horizontal reflection. But actually, algebraically, these two things are the same. Right? A negative on the outside and a negative on the bottom are the same. And that's interesting because a horizontal reflection of the green graph, the part on the right will reflect to the left, and it will exactly overlap the other graph that's there. And the part on the left will reflect to the right, and you'll get again an overlap of the two graphs. And so because of the origin symmetry on that original reciprocal function, a horizontal and vertical reflection end up really being the same thing. They do the same thing to the graph. Okay, they have the same result. But there are some other really interesting functions and cool applications to transformations. So let's take a look at a couple. Let's pick on, let's see, which function should we pick on? Maybe the cubing function, x cubed, right? The x cubed function, we've seen from our library of functions, kind of looks like a half a parabola, but it's steeper. And then the other half, oops, goes down and to the left. It's a mirror image through the origin. Okay, so that's roughly our x cubed function. If I were to make a new function, let's say that g of x is equal to maybe f of x plus 3, then what we've done is we've shifted the graph to the left 3. And so this is actually x plus 3 all cubed. So this function is a left shift by 3 units. So I'll come over 1, 2, 3, put my dot, and then basically draw the same graph, just shifted over. Okay. If I wanted to combine some of these transformations, I can do that. Let's say we had something like, let's call it h of x. And let's do 1/3 f of negative x plus 1. Okay, so here, let's get rid of the red graph. Here I would be reflecting the graph horizontally. That's what the negative on the x does. Oh, and I should probably write the actual function out. So it would be 1/3 quantity negative x cubed plus 1. Okay, that would be my function. So the first application here, this reflection is going to reflect it horizontally. I'm going to do all the different steps dashed this time instead of in different colors, and then the final graph will be solid. Okay, so here I have the reflection, that's the negative. Then the 1/3 will, because it's on the outside, it vertically compresses by a factor of 1/3. So if you imagine pulling everything 1/3 of the way closer to the x-axis, you would have a wider graph. Right, that's a vertical compression. Each point gets pulled toward the x-axis. And then you have a plus 1. So you take that last graph, and in fact I'm going to erase the other one in between. And you would, oh, I just erased the wrong part. There. So you would take that last graph, the wider one, and you would shift it up 1 unit. So we go up 1. Oops, that is not wide enough. I'm trying to mimic this here. There we go. And there it is. Oh, I was going to do that one solid, wasn't I? Final graph is solid, so there it is. Okay, so that would be the graph, that black one, solid black, is the graph of this function here with a horizontal reflection, a vertical compression, and a vertical shift. Okay, so all of these things can be combined into the same function. Now what's interesting, I kind of like this, is the idea of throwing an absolute value on a function. Okay, so let me give you an example. If I were to throw an absolute value on, let me regraph something here. Let's do that reciprocal function. I'm just pulling some functions out of our library of functions right now. So if I go with if I go with f of x is 1 over x, we know what the graph of that looks like. Then let's take a new graph to be the absolute value. So let's say g of x is the absolute value of 1 over x. Well, basically what you're doing is any output that's positive remains positive, and any output that's negative switches to a positive, right, when you take the absolute value of it. And so the positive stuff over here on the right stays there, doesn't do anything, because the absolute value of a positive number is itself. But on the negative side, everything down below the x-axis, the outputs have to become positive. So if they're negative to begin with, they reflect and become positive. And so g of x, oops, I should probably redraw this on a different graph, otherwise everything's going to overlap. So g of x is going to have the same part of the graph on the right side, but on the left side it's going to be above the x-axis instead of below the x-axis. Okay, it doesn't look real good there, but hopefully you get the idea. So it flips everything above the x-axis. Okay. In fact, no matter what the function is, if you flop absolute values around it, then everything from the bottom, everything from below the x-axis reflects above the x-axis. In fact, I could just draw some random function or some random graph. Let's say we had I don't know, something that maybe goes like this. And let's call this f of x. Okay, here's my graph. Then if I wanted a new graph, let's say that g of x is the absolute value of f of x, then each part of the f of x function that's below the x-axis just reflects above it. And so this little dip here where it goes below just bounces and reflects up above. This part here that goes below reflects up above. Okay, and so the graph of the absolute value would be those two pieces, and then I would kind of shade over top of this blue, which I don't want to erase the blue, so I'll do this carefully. So what you see in red is the new function with the absolute value, and what you see in blue is the original function. So it literally takes everything from below the x-axis and reflects it above. Okay. All right, so that pretty well summarizes all of our transformations. There might be one other thing I'd like to show you, and that is how to apply transformations to a function rather than to a graph. And so if I started out, let's say my function f of x was the cube root of x, and I wanted to apply, let's say, 3 transformations, and I put them in a particular order. So maybe I want to, let's go with reflect vertically. And then number 2, let's do a horizontal compression by a factor of, let's see, compression by a factor of 2. And then the third thing is going to be a vertical shift down 5. So if I put all of these together in that order, I can create a new function. Okay, so I'm going to call that new function g of x. And what I want to do is take these one at a time. So a vertical reflection is going to be a negative on the outside of that function. So that would be a negative cube root. A horizontal compression by a factor of 2. Well, remember, compressing horizontally multiplies by 2, whereas compressing vertically would divide or multiply by half. So compressing horizontally is a multiplication by 2. So I want 2x in there. And then a vertical shift down 5 drops this graph down. So I would subtract 5 on the outside. And so this graph, or this function, should have these 3 transformations in order. Okay. If I did them in a different order, I may actually end up with a different function. Maybe I'll give you an example there. Let's say I were to switch 2 of these. Let's switch 1 and 3 around so that we do the shift first, then the compression, and then the reflection. Okay, let's call that h of x. Okay, so h of x, I'm going to reverse these steps. So you do the vertical shift first. So h of x is going to be, well, first thing we do would be the cube root of x and minus 5. Okay, that's your shift down from this one. You shift down 5. Then you do your horizontal compression, so you can do that inside, right, along with the x. So you replace the x with 2x. So that's okay. Oops, I don't really want to call that h of x. I'm just going to build this up. So the cube root of 2x and then minus 5. And then you do your vertical reflection. Well, once it's already shifted, the vertical reflection is going to be a little bit different because now it applies to the whole thing. It applies to this whole function. And so I need to multiply that entire function by a negative, okay? And when I do that, it's going to distribute to the other term. So I end up with a negative cube root of 2x plus 5, okay? So doing the transformations out of order will change the function. So sometimes, and sometimes it won't. It depends on different symmetries within the function, different properties of the function. And so we have to be careful to make sure that they go in order or in proper order rather than mixing things around randomly. Okay, so the order is actually important there. Okay, so hopefully that gives you a pretty good idea of transformations of graphs. Again, we're going to be doing a lot of transformations throughout the course, and we can put them together. So you've got your horizontal shifts, your vertical shifts, and then you've got your horizontal and vertical compressions and stretches, and then you've got your horizontal and vertical reflections, in addition to those absolute values that are out there. Okay, so just be aware of that, and that should cover all the transformations.